My name is Natalie Kremen, and I am going to spend the next few minutes teaching you about hydrogen bonding and a couple of its major effects in biology. The concept of electronegativity is key to understanding hydrogen bonding. Electronegativity can be best described as how much an atom wants to hog its electrons. To get this idea started, take these two dogs as an example. The dog on the left, a Chihuahua, is very small and not strong at all. On the other hand, the bull mastiff on the right represents a huge dog with lots of strength. Now, imagine these two dogs playing tug-of-war with one another. The bull mastiff would clearly win and pull the rope toward itself with ease. If the rope represents electrons, then the bull mastiff would be very electronegative because it pulls the electrons close to itself, while the Chihuahua would not be electronegative because it does not pull the electrons toward itself very hard. Now, back to chemistry. As you look up the periodic table and to the right, the electronegativity of atoms increases. This means that atoms such as nitrogen, oxygen, and fluorine are very electronegative and have a strong will to hold electrons close. Hydrogen is not an electronegative atom. Now, let's take a look at what happens when you put an electronegative atom with an atom that is not electronegative. When we have an electronegative atom bonded to a non-electronegative atom, the electronegative atom will hog electrons, pulling them through the sigma bond. This will create a partial negative charge on the electronegative atom because it is pulling electrons close to it. Likewise, this pull will create a partial positive charge on the non-electronegative atom because it is getting electrons pulled away from it. What does this create? A polar bond. If you put two molecules with a polar bond together, the partial negative charge can interact with the partial positive charge to create a weak force holding the two molecules together. These are dipole-dipole interactions, and this is where hydrogen bonding comes in. Here are two pictures of hydrogen bonding in action. The picture on the left shows the nitrogen atom being electronegative, hogging electrons from the hydrogen, and how it creates partial positive and negative charges. When we look at two molecules together, we can see how the partial negative charge on the nitrogen from one molecule interacts with the partial positive charge on the hydrogen of another molecule. This situation is similar with the molecule on the right. The oxygen, being a very electronegative atom, hogs electrons toward it to create partial negative charge on the oxygen and a partial positive charge on the hydrogen. Now the partial negative area of one molecule can interact with the partial positive area of another molecule. You can see the hydrogen bonds with the dotted lines show. But why is this important to biology? In DNA, two strands of the double helix are actually held together with hydrogen bonds. One of four base pairs is connected to each deoxyribose sugar on the DNA backbone. These bases, containing nitrogen, oxygen, and hydrogen atoms, can hydrogen bond with each other to hold the two strands of DNA together. The dotted lines show the hydrogen bonds. As you can see, the purines, adenine and guanine, which are made of two rings, always bond to the pyrimidines, cytosine and thymine, which are made of one ring. This allows for the DNA double helix to have a constant width all the way up. Hydrogen bonding is also very important in the structure of proteins. After a protein's amino acid chain is created, the oxygen, nitrogen, and hydrogen atoms on different amino acids can interact to form hydrogen bonds and fold the amino acid chain. Alpha helices form when amino acids 4 places from one another form hydrogen bonds with each other. You can see this with the diagram on the left. Beta-pleated sheets are another shape the amino acid chain can create when hydrogen bonds are formed. The hydrogen bonds in these diagrams are shown by the yellow lines on the left and the pink dotted lines on the right. Hope you enjoyed the video and have a great rest of the quarter. Thank you.